In this video, I'm going to continue with question number 14, problems 2.3 from elementary number theory by D.M. Borton. For any integer a, show the following. The first one, GCD of 2a plus 1 and 9a plus 4 is equal to 1. So what we do here, let the GCD of 2a plus 1 and 9a plus 4 be D. If D is the GCD of these two, then D divides both 2a plus 1 and 9a plus 4. Okay? And we also know that if D divides A, D divides B, then it implies that D divides AX plus BY, where X and Y are integers. This is what that we have known before. Alright, we use this one. It implies that D, you assume this one as A, this one as B. So we have A. Now find the value of X here and find the value of Y such that you won't have the term containing A. So here we have to multiply by 9. Okay, this is our X, and then our B is 9A plus 4. Alright, now here we have to find the value of Y. So clearly our Y would be minus 2, because from here we have 18A, and if we multiply by minus 2, then here we have minus 18A, so that there would be no term containing A. And then here we have 18A plus 9 minus 18A minus 8. Okay, you multiply. This one and this one get cancelled. 9 minus 8 is 1. Okay, the only number that divides 1 is 1 itself. So from here it implies that D is 1. Okay, so hence therefore the GCD of 2a plus 1 and 9a plus 4 is what? In place of D, here in place of D you put the value to be 1. Hence we have proved, or we have shown, the first one, this one. Okay, now let us do the second one. See, okay, second one in a similar way. Alright, let the GCD of 5a plus 2 and 7a plus 3 be D. So D divides both 5a plus 2 and 7a plus 3. Again, like before, like in 14a, D divides. Now here we have A to be 7a plus 3. Okay, now you have to find X here. Okay, such that when you multiply with this you get a number, and here also find Y such that when you multiply with this one you get a number, and then the term containing A would be eliminated. So here we have to multiply by 5. This one placed as A, this one as X. Okay, plus what is B? 5a plus 2. And here we have to find a number, the value of Y, such that when you multiply with this one you get 35 minus 35, and then with this one it would be cancelled. Okay, so the number that you have to multiply here is by minus 7. Okay, this one plays as B, this one plays as Y. So from here we have 35A plus 15 minus 35A minus 14. Okay, so 15 minus 14 is 1. The only number that divides 1 is 1, so a D should be 1. So therefore, what is the GCD of 5A plus 2 and 7A plus 3? It is 1. We have shown the second one. Okay, alright, now let's do the third one. If A is odd, then show that the GCD of 3A and 3A plus 2 is 1. Again, similar procedure. What you do, let the GCD of 3A and 3A plus 2 be D. So in that case, D divides both 3A and 3A plus 2. Again, now D divides, here you can assume that this is your A. Multiply with some value of X, say it is 1. Okay, and then here you assume that this one is B, and then multiply with Y. You have to multiply with minus 1, so that minus 3A gets cancelled with 3A. Okay, and from here what do you have? D divides 3A plus 2 minus 3A. Okay, so D divides 2. Now the only numbers that divides 2 are the positive numbers. Okay, are 1 and then 2. But in the question they say that A is odd. But A is odd. So if A is odd, what do you expect about 3A? It is odd. Is odd. So if this one is odd, then 2 does not divide 3A because 2 is even and 3A is odd, so it does not divide 3A. So the only value of D that we have to take here is 1. Okay, so therefore GCD of 3A and 3A plus 2 is 1. This one is also shown.